Okay, so let's look at another problem. So suppose that the 3 microchips in production, run of 40, are defective. Okay, so a sample of 5 to be selected to be checked for defects, right? So number 1, how many different samples can be chosen? So you have 40, right? So you just choose 5 of them. So it's a 40 chooses 5. Okay, so it's a 40 factorial, 35 factorial, 5 factorial. Right? Of course, you can calculate the number, and then so I mean I calculated it here. Okay, so it's a 36, 37, 38, 39, 40, and then over 1 times 2 times 3 times 4 times 5, right? So yeah, so you can do the simplification here. Okay, I'm not going to do that. Okay, so you do that. Then part B, how many samples will contain at least 1 defective chip? So again, when we're talking about the at least, you can think about it into 2 ways. So number 1, you know that you only have 3 chips are defective, right? So at most you're gonna have 3. So we're talking about at least 1 defective chips. You can do 3 chooses 1, and then the other is 37 chooses 4. Okay, so this is the situation. You have 1 defect, and then 3 chooses 2, and 37 chooses 3, right? And then you can do 3 choose 3. So all of them are, 3 of them are the defects, and then so 37 you pick the 2. So this is one way to think about it. Okay. The other way to think about this problem is using the what is it called, the complement, right? So talking about the complement here is the complement of this part at least. That means there is no defective chip, right? So you can also think about it. It's using the total weight of the selection minus 37 chooses 5. That will also give you what you have here. And then number 3, what is the probability that a random choosing sample 5 contains at least 1 defective chips? Fairly simple, right? So use the result of B over the result of A, right? So that will do the work. Okay. So again, still a shorter video. So hope you enjoy it. Thanks.